All right, we sort of introduced this idea of the dot product and angles, but we're really going to go all in on it now. So we're going to actually define the angle between two vectors as the result of a dot product. So let's say we have two vectors. Let's say V and W are vectors. Okay? We define, and actually we define the cosine of the angle between them. So we define the cosine of theta between them by the cosine theta. I like to write VW, but I don't think you really need to. And that's going to be V dotted with W divided by the magnitude of V, magnitude of W. I wrote two lines here. That's really the same. Another thing to keep in mind is you could also write it like that without the arrow. I don't really like that notation for this class because it's a little bit too subtle. In the book, though, they might write it, for example, with boldface when they're talking about the vector, and then not boldface when they're talking about the magnitude of the vector. Okay, so you might see something like V as the vector, and then V as the magnitude, something like that. And I kind of think that's a little too subtle to be doing in a calculus book, but I can change things when I write my own calculus book, which I'm never going to do. Okay. All right. So let's say we have let's say we have 7i plus j. Let's call that V. And W is I minus 4j plus k. All right, so let's find V dotted with W, and we're going to find the cosine of the angle between them. So V dotted with W is then going to be, of course, 7 times 1 plus 1 times negative 4 plus 0 times 1. That's going to be 7 minus 4, 3. Okay. The cosine of the angle between them is going to be 3 divided by, now the magnitude of V. Magnitude of V here is what? 49 plus 1 is 50, so the square root of 50. Magnitude of W is going to be 1 plus 16 is 17, plus 1 is 18, the square root of 18. Okay, and that'll give you the angle between them. So the angle between them is the inverse cosine of 3 over the square root of 15, square root of 18. Okay? All right. One last thing then, or one next thing. Remember, two vectors are perpendicular, two lines are perpendicular if the angle between them is 90 degrees or pi over 2, right? Cosine of 90 and cosine of pi over 2, depending on whether you're in degrees or radians, is 0. Okay, so two vectors write that again. Oh, I don't want to use U there. Are perpendicular. And you often see that symbol used if v dotted with w equals 0. Now, if we go back to our original dot products, right? Remember I, j, and k? This sort of just goes right along with it. Let's do it in 2 dimensions. I is this vector, right? J is this vector. And their dot product is 0 and they're perpendicular. Of course, K is this vector. So here I'm doing X, Y, Z. Remember, right-hand rule, this works. Okay. You can't see my hand. And it looks backwards to you, but whatever. Okay, X, Y, Z. So the Z has, of course, 0, 0, 1. So these 3 vectors are perpendicular. Okay, and you can only find 3 mutually perpendicular vectors in space. Okay, if you can find more, you actually have a higher dimensional space. Okay, and I'm not going to try to draw that. All right. Okay, I'll see you all in the next video.